Hi, 8th grade, Mr. Agnos here. Last week, you guys learned how to solve equations with variables on both sides of the equal sign. Today, we're going to go ahead and look at some situations that would create an equation with variables on both sides, and then we have to solve the equation. In other words, we're going to be given a little short story. We got to write an equation that models it and then solve it. In all of these equations, we'll have variables on both sides of the equal sign. All right, it says suppose the temperature in your town is 21 degrees Fahrenheit and rising 1.5 degrees Fahrenheit every hour. Okay, so let's just go ahead and write a little expression that represents that. So we're going to say your town. So I'll go ahead and I'll call that your town. And we live in Wisconsin or something because it's really cold. And it says 21 degrees and rising 1.5 degrees every hour. All right, so let's create a variable here and let it represent the number of hours. So I'm going to say x is equal to our number of hours. Okay, and our equation would start off at 21. And then every hour that goes by, we're increasing by 1.5. So we're going to be adding 1.5 degrees every hour. So this is what this is actually what's called an expression. Notice there's no equal sign here. This is the expression for your town. Well, your friend lives far away, maybe the other side of the country, and in their town, so I'll write friend. All right, friend right here. It's 28 degrees and falling. That word falling is going to be key. And falling 2 degrees every hour. So how would we write this? Well, we start with 28. And then since it's falling, we're going to subtract instead of adding, right? Here, the temperature was rising. So that's why we added. But for our friend, the temperature is falling, so we're going to subtract. I don't know why it did that. So we are going to subtract. So I'm going to subtract 2 degrees every hour. All right. So this expression gives the temperature in your town, and this expression gives the temperature in your friend's town. In how many hours will the temperatures be equal? Well, the key word right here is equal. So all we're going to do is take this expression and set it equal to this expression by putting an equal sign right here in the middle. So I'm going to go ahead and rewrite this as 21 plus 1.5x is equal to 28 minus 2x. And if we solve this equation, it will tell us in how many hours the temperature in the two towns will be exactly the same. Okay, so the first thing I want to do is I want to look at my variable terms. Notice I have a positive 1.5x right here and a minus 2x right here. So I'm thinking to myself, if I add 2x to both sides, it'll get rid of this one, and then I'll have a nice positive x term on the left-hand side. So I'm going to go ahead and add 2x on the right and add 2x on the left. All right. I still have 21. 1.5x plus 2x is 3.5x, right? Basically, we're just doing 1.5 plus 2, but we're talking about x's. So I have 3.5 x's is equal to, nothing happened to my 28, and minus 2x plus 2x, those cancel. And that was the whole idea. Because now I have an equation where there's only an x on one side, right? I have 3.5 x's on the left-hand side, but I have no x's over here. Now we have a two-step equation. We always want to get rid of the number that doesn't have a variable by adding or subtracting. So in this case, if I have 21, then the way to get rid of it is to subtract 21. 21 minus 21 cancels. I'm left with 3.5x is equal to 7. Okay, x times 3.5, so we're going to divide by 3.5. Divide by 3.5. By multiplying, divide by the same number, they cancel, and I get x is equal to, and you can use a calculator here if you want, but 7 divided by 3.5 is 2, right? 3.5 times 2 would give me 7. So what this means is that, remember, x is our number of hours right here. So in 2 hours, the towns will have exactly the same temperature. Okay, that's one example where you're going to see an equation with variables on both sides. Let me do a second problem. And again, I do go a little faster in the videos because I'm counting on the fact that you guys could always pause, rewind, and so on. Okay, so I know that was really quick, but what we had there was 2 towns. Again, we're talking about towns, but this time we're not talking about their temperatures, we're talking about their populations. And it says a town's population is 14,000 and it is increasing by 160 people every year. So let's go ahead and write an expression for this right here, right? 14,000 and it's increasing by 160 people every year. So the first thing we need to do is figure out, well, x is going to be our variable, and we'll let it equal the number of years here. And they don't give me a name for this town, so I'm going to call it town A, and then we'll have a town B. So this is town A. And it starts off at 14,000 and increase. It says increase right here. That means we're going to add 160 people every year. So that's plus 160x, because remember, x is our number of years. So this expression gives me the population of town A after x years. Well, a nearby town, we'll call that town B. It has a population of 24,000 and it is decreasing by 200 people every year. Okay, so we start off with 24,000 and it is decreasing, so we're going to subtract. Remember over here where it says increasing, we added, well, since it's decreasing, we're going to subtract 200 people every year. Maybe there's a factory that closed or something, and so people started moving out of town. Okay, so these are my 2 expressions. In about how many years will the populations of the towns be equal? So I just want to take this word equal and turn it into an equal sign in between my 2 expressions. So I'm going to go ahead and rewrite all of this as 14,000 plus 160x. When will that be equal to 24,000 minus 200x? All right, when will the population of town A be equal to the population of town B? Okay, so again, I'm going to start with my variable terms. I have a positive 160x right here and a minus 200x right here. So I always think in this situation, the easiest thing to do would be to add 200x to both sides. It's going to get rid of it on the right-hand side, and we'll have a nice positive number over here. All right, so I'm going to add 200x to both sides. On the left-hand side, I have 14,000 plus 360x. And on the right-hand side, I have, these are going to cancel, right? Minus 200x plus 200x, those cancel. So I just have 24,000. Don't let these big numbers scare you. This is just a 2-step equation. Step 1 is always get rid of the number with no variable, right? By adding or subtracting. So I'm going to, since I have 14,000, I'm going to subtract 14,000 to get rid of it. And I do that from both sides. That leaves me, these cancel, And I now have 360x is equal to 10,000. All right, last step. Since I'm multiplying x by 360, we're going to divide by 360. And I'm just going to go ahead and bust out a calculator for this one. Those are going to cancel. Notice that it says in about. So we can approximate here. So when you get to a question like this on a homework, be careful, because they're going to tell you what they want you to round it to. So I'm guessing some kids are going to get this wrong because they're going to round incorrectly. For here, they don't really give us what they want us to round to, but on the homework they will. All right, 10,000 divided by 360 equals 20. I don't know if you guys can see this, 27.7 repeating. So the way we write that is 27.7 repeating. So this rounds up to about, this is the symbol for about or approximately, about 28 years. So if these towns continue to go by these growth patterns, in 28 years they will have exactly the same population. Notice this town is starting off with a smaller population, and this town is starting off with a larger population. But this population is decreasing, whereas this population is increasing. Okay, I'm going to try and squeeze in one last problem. Again, I know I'm going fast, but I'm counting on the fact that you guys can pause and rewind and whatnot. Okay, for this problem we have two trees. Notice one tree is taller than the other, but the tree that was smaller is growing faster. So it actually went from being smaller to being bigger. All right, a tree is 4 feet high when planted. It grows at a rate of 2.5 feet every year. So again, we're going to let x equal the number of years. And we'll have tree A. And it starts at 4 feet and grows 2.5 feet every year. So that's 4 feet plus 2.5 every year. All right, a second tree, so we'll call that tree B. It's obviously a B. Is 6.5 feet, so it's taller, but it grows at only a rate of 2 feet every year. So it starts off taller, but it's not growing as fast. In how many years will the trees be equal? So we take our equal sign and we put it right in the middle. So again, this one's shorter, but it's growing faster. This one's taller, but it's growing not as quickly. So I get 4 plus 2.5x is equal to 6.5 plus 2x. Okay, since both my variable terms are positive, I have a positive 2.5x and a positive 2x, I'm going to subtract the smaller one. So I'm going to subtract 2x from both sides. I get 4 plus 0.5x, right? 2.5 minus 2 is just 0.5, and we're talking about x's. And then these cancel, so on the right-hand side, I get 6.5. We want to get rid of the number with no variable, so I'm going to subtract 4 from both sides. Oh, that's a division sign. We're going to subtract 4. Make sure to line up your decimal correctly over here. 4 minus 4 is 0. Those cancel. So I get 0.5x is equal to 6.5 minus 4 is 2.5. And the last step, since I'm multiplying x by 0.5, I'm going to divide by 0.5. And again, you could use a calculator for this, but think about money. If I have $2.50 and I divide it by 50 cents, well, that goes in there 5 times, right? So in this case, x equals 5. And remember, x is the number of years. So in 5 years, these trees will be exactly the same height. Okay, guys, I know I went really fast, especially there towards the end, but I'm hoping that you guys will pause when you need to, or go back and watch the questions again. Okay, hit me up in the comments, send me an email, or ask me questions in class.